about some little robots that we have up on the ISS, in the International Space Station, that we launched last year with NASA. So I work for NASA Ames Research Center, one of the NASA centers in US, in California in particular. And I'll give a brief introduction about Astro B. Okay, so hopefully you can see the screen and all the animation work. Okay, so Astro B is basically an autonomous free flyer for the International Space Station. We launched 3 of these free flyers last year. And so we have 3 of these up on the space station. One is called Bumble, one is called Honey, and one is called Queen. And we currently have 2 of them commissioned. So we are using both of them to do a bunch of different science experiments and help astronauts to do different type of measurements inside the ISS. So Astro B, this is a kind of breakdown view of the robot. It's kind of considered also in a easy way, simple way to describe it as a space drone, or other people even call it funnily a space Roomba. So it's basically a free flyer that has in the central section, it's kind of composed in 3 different sections. So there is a central core of the central section, which is this white one that you see. It's basically packed with all the computers and the sensors. So we have 6 different cameras, a LiDAR, a touch screen, a flashlight, a microphone, and so on. And then we have on the two sides, so these 2 kind of rectangular modules that you see on the sides, those are the so-called propulsion modules. So they are basically impeller motors that spin and suck air from inside the space station from this grate that you see on the side. And then the chamber here becomes pressurized, and through nozzles all around, we can basically control the robot in every direction. So we can move or rotate in every direction. And then we also have some kind of like empty spaces here that you see on top and on the bottom. And these spaces are so-called payload bays. And those are used for guest scientists to develop an experiment or a payload or an instrument and attach it on the robot. And they can basically use the robot to test their experiment in microgravity on the ISS. So for example, here in this picture, we have, as an example, this robotic arm that is attached on the robot through this payload bay. And we can use this robotic arm to grab or perch onto handrails, for example, inside the space station, or in the near future, we want to use it to move cargo around. So that Astro B can move cargo around to inside the ISS. So as a kind of outline of the different uses of Astro B, as I mentioned, Astro B is used as a robotic research facility inside the ISS, and we replaced the old facility called Spheres that was used on the ISS for more than 10 years. Astro B is also packed with a lot of cameras, and so it can be used as a kind of drone, so as a remotely operated camera. And then after that, also the Astro B will be used also for to take measurements. So it's a mobile sensor platform inside the ISS. So as an example, I'll show you here a few payloads or so-called experiments that we are going to attach and use on Astro B. One is called RFID tag reader from Johnson Space Center. It's basically an array of, it's a set of different antennas that irradiate in some specific frequencies and can be used to locate its so-called RFID tags. So imagine these tags that you can also see on your clothes or other things, in normal stores. And so if you put these tags on all the objects inside the ISS, and then you have AstroB going around and radiating with these antennas, you can basically do a very accurate inventory of all the objects inside the ISS. And so you can do a very accurate localization of everything that is inside the ISS. Another cool experiment that we're gonna use AstroB for is called 𝐀𝐬𝐭𝐫𝐧𝐚. It's an experiment payload with Stanford. It's basically a new type of adhesive. You can see it in this picture here on the left. It's this black kind of gripper that can basically attach or stick onto very smooth surfaces. And this could be used for many different applications, from orbit removal or even just grappling on the surfaces inside the ISS to move around and keep things in order. And then another one worth mentioning is SoundSea. It's a payload from Bosch and Robotic, and it's an array of ultrasonic microphones. And this payload can be used to create sound maps of environments inside the ISS, or even to monitor the health of some specific systems inside the ISS. So if you listen to the sound emitted by some specific machines, for example, the treadmill or the eclipse, which is the life support recycling system inside the ISS, you can basically forecast or predict the working of the systems. So if something is going to fail, by listening to the sound emitted by these machines, you can tell how and when and how bad is going to be the failure. And then also AstroB is very important international collaboration with other robots or free flyers inside the ISS. So we have here on the left the Simon free flyer, which is from the European Space Agency. Then we have the InBall from JAXA, and then AstroB here on the right. So we are planning to do some kind of collaborations between all these different free flyers. And then just quick video showing you AstroB in operation. This is one of the sessions that we did last year. So you see AstroB is starting here on this right side. It's a dock station that provides power and high-speed communication. And so the robot autonomously docks from the dock station and then starts moving and flying around the ISS to perform different type of tasks. So in this example, in this session here, it was just kind of testing the movements and the performance of the localization. So it's just moving around and doing some kind of camera survey of this module in the ISS. So yeah, so just kind of like as a summary of what AstroB can do and will do. So imagine in the near future, we will have a lot of deep space exploration missions. In particular, we will have the Lunar Gateway coming up in the next years. It's a new space station that will orbit the moon. And then hopefully we will start going onto Mars in the next decade or so. So the concept of caretaker robots will be very important. And so AstroB will enable and will test a new platform to do monitoring of the environment. It can do also a kind of inspections like survey or localizing problems. And then it's also a kind of demonstration to do robotic manipulations, like, for example, maintenance or repairing some issues inside the space station, or even cargo transfer. And also important is AstroB is very going to be very well used to do student competitions. Called one of this student competition was actually done very recently in October of this year. It's called the 𝐀𝐬𝐭𝐫𝐧𝐚 Robot Programming Challenge from JAXA, and it's a student competition with among many different students across Asia, from United Emirates and Indonesia, Japan, and Australia, and so on. And so all these students need to write a code to operate AstroB and fly it inside the space station. And so with this, I thank you all for your attention. Sorry for the sound. And I think we have time for a video and then some open questions.
Flying more than 250 miles above Earth, the International Space Station is both a research lab and a stepping stone for future trips to the Moon and Mars. NASA is developing 3 AstroB robots that will fly inside the space station alongside astronauts, opening research opportunities for guest scientists and saving astronaut time by doing routine tasks. The AstroBs will replace the spheres, the current robots, and most used ISS payload. Fully autonomous, each 1-foot cube is packed with sensors that open up new areas of research. The AstroBs provide a zero-G research facility for guest scientists, give ground controllers additional eyes on the spacecraft, monitor radiation and air quality that help keep astronauts safe, and can even find lost items. The built-in arm normally occupies the top bay, but can also be swapped for a guest scientist's own experimental hardware. Like a quadcopter, AstroBs fly in air, except there is no gravity on the ISS. As a result, they are not limited by lifting power. Larger payloads can attach in a tractor-trailer configuration, and multiple AstroBs can even work together. 2 centrifugal impellers drive air through 12 adjustable nozzles that work together, allowing the robot to instantly move in any direction and turn on any axis. The AstroBs will continue the Sphere's tradition of hosting the annual Zero Robotics competition, drawing together thousands of students from 18 countries who can watch their code fly on the space station. Launching in 2018, AstroB is the next-generation robot meant to make life in space easier for astronauts and, at the same time, build a foundation for new scientific breakthroughs in autonomy and robotics.
Okay, perfect.
Sir, you're actually on.
Thank you, Roberto. It was really interesting to see about AstroB and to see it moving autonomously inside ISS. That was amazing. I would like to know, how do you think AstroB will catalyze research in field like robotics? What is your view on that?
Oh, okay, yeah. So that's a really interesting question. So although AstroB is a very general science platform, so it can basically host any type of payloads or experiments, scientific experiments. So from I don't know, new type of fluidic systems to, for example, these new antennas. It will also be used a lot to test new type of robotic systems. So one of the examples are these robotic arms that we are already launched actually, and we are going to test them on AstroB in the next future. And for example, there is another interesting payload called Astrobotics. It's basically it's from the Naval Postgraduate School in Monterey, California, and they want to use the robotic arm on AstroB to move inside the space station basically without propellant, without using any type of propellant. It's kind of like moving as a monkey. So they want to use the arm to kind of like swing from one side of the space station to the other, and then just, you know, grab onto the other side with the robotic arm. And so it's kind of very interesting, you know, technology that can enable completely new type of ideas or concepts for future space stations. So if you imagine, I don't know, kind of like space monkeys in a way, robotic space monkeys that move around the space station, and they can be inside the space station or even outside the space stations. So this is just one example. And other than that, we actually, there's another project called 𝐈𝐧𝐭𝐞𝐫𝐧𝐚, and this is for the Lunar Gateway coming up in the next years. And 𝐈𝐧𝐭𝐞𝐫𝐧𝐚 wants to gather the functionalities and the potentiality basically from different robots that are already on the space station of the ISS, but they will also transition and go on to the Lunar Gateway. So we want to bring together the work from Argonaut, which is this kind of humanoid robot on the space station, and then AstroB together, and then other coming robots on the space station. So if we kind of like put all these robots together and we have them collaborate and communicate, you know, instantly to monitor and monitor and maintain the station, for example, it's a completely, you know, breakthrough for future space stations, I think.
Okay. So AstroB has been on board for quite some time now. So what difference has it created to the lives of the astronauts on the space station? What do you think?
Well, so actually, so AstroB has been on the ISS for a bit more than 1 year. But unfortunately, it's been only recently since we finished the commissioning of one of the AstroBs. And so there was actually just very recently, it's been probably a few months since we started using one of the AstroB for experiments or for the keyboard PC, for example, for the student competition with JAXA. So unfortunately, I cannot say that AstroB has done a huge change in the astronaut life yet.
Not yet.
Not yet, but it's going to do it very soon. And one main activity that we have done, the keyboard PC challenge with the JAXA and all these students from different countries, this is probably one of the biggest impacts that has done on the astronauts. So it's been a great event for them, outreach events that brought all these astronauts together to talk live and work and inspire kids all around the globe.
So now that robots like AstroB have become a reality, has it anyway changed or affected the research experience of the astronauts on board?
Well, the experience, sorry, you mean, what do you mean by experience?
Their work see, astronauts on board ISS also do a lot of research. Okay. So because now there is a robot available, has it affected their research experience?
Oh, I see. Sorry. Yeah. So it will, unfortunately, not yet, because we are still waiting for all these experiments and researchers to operate AstroB soon. But yes, it will definitely influence a lot how astronauts do the research and work on the space station. For example, another really cool payload that I mentioned in the presentation is called 𝐍𝐶, and it's used to do sound surveys inside the space station. And right now, the astronauts need to do that manually. So they have a kind of a sound meter that they grab, with the hands, and they go just around the space station, in every single module, one by one, and they take measurements of the sound in the different modules manually. AstroB is going to do that, instead of them, and it's going to just flying around autonomously in the different modules, take measurements, and then go back to sleep onto the dock station. And so this is, in a way, it's actually not very fun experience. It's kind of not a very exciting or fun work for astronauts in a way. So if a robot or an autonomous system can replace them to do this, it's probably a good thing, I guess.
Yeah, it can relieve them from the routine and mundane tasks. This is a very routine and dull task. Okay, right. It's very intriguing, the names that you have given to the three robots, Honey, Queen, and Bumble. What is the reason behind these names?
Yeah, so when we came up with the name of the project AstroB, we were imagining a few of these robots flying around and just work together, communicate with each other like bees. So we basically decided to give the name of to our three AstroBs as the three bees. So three type of bees, I guess. So one is the bumblebee. It's one of the bees. The other is honeybee, and then the third is queen bee. So there's three names of bees that gave the name to the robots.
Right. Okay. Right. Now you see, there is a lot of risk to human life when we have humans operating in ISS. So can we see that development of a robot like AstroB, can it be considered to be a step towards having a fully autonomous space station where there are no humans? Is that the direction in which we can eventually go?
Well, so I think, a project like AstroB, I don't think will replace humans or human space flight at all. They will help them. They will, help astronauts to do some, repetitive and boring tasks, and give astronauts more time to focus on other more, human type of work. And so I don't think that these robots could replace astronauts in the future, but they will definitely try to automate and help the monitoring and maintenance of space stations when astronauts are not even around. For example, the Lunar Gateway, which is the new space station that will orbit the moon, there won't be astronauts living there for almost 90% of the time. So astronauts will be in the space station in the Gateway just for like a month per year, and all the rest, the other 11 months, we need to just keep everything under control and monitor the station remotely. And so if we have little robots that can help us to do that, and predict if something is going to fail, or if we need to make maintenance of something, maybe they can definitely help in that.
Surely. All right. Tell us what were the major challenges that were faced by the design team and the scientists and engineers while developing AstroB?
Yeah, that's an interesting question. So definitely one of the biggest challenges is that AstroB was kind of initially designed. It was kind of in our mind was the purpose was to test as many different experiments, as many different payloads as possible, and so it's kind of non-trivial problem because you want to include as many capabilities, as many functionalities as you can, but you don't want to make it this just never-ending problem and just like trying to pack too many sensors and allow too many type of experiments, and so we had to do a big, very important trade-off on that, and so yeah, one of the biggest challenges was the design actually. So we just had to make very important decisions on what kind of experiments or what kind of payloads we could accommodate with AstroB, and so we had to finally select the number of sensors, the way it flies, and all this kind of stuff.
Those were the main challenges. Okay, so you said that robots like AstroB are going to take care of some mundane tasks remotely and also autonomously. You also mentioned that on the Lunar Gateway, they're going to be there for 11 months. Don't you think it's a bit risky to leave all these routine tasks in the hands of these kind of robots?
Yeah, I mean, I think it's definitely good if we have redundancy. So maybe we wouldn't want to leave all these tasks to these robots, but if we can have them kind of as a double security layer, and make sure that the robots together with other kind of like security and safety systems work together in collaboration, then maybe this is the best way we can do this, because if there is no human on the space station for 11 months, the only solution I see is to have autonomous systems or robots to do this.
All right, and also just take us through this is like a overall wrapping question. So what were the key reasons, according to you, for the ideation and development of robots like AstroB? What was the key motivating factor?
Yeah, so AstroB was one of the main objectives of AstroB was to replace the previous free flyer platform called Spheres. So Spheres there were also three spherical robots that we had up on the ISS for almost 14 or 15 years, I think, and their main purpose was to allow scientists to test experiments in microgravity very easily, and so basically AstroB was also came up as a replacement, as a new innovative advanced platform for that. So definitely one of the main objectives that we had in mind is to provide a more advanced science platform that was going to replace the Spheres robots actually.
Okay, so it was a higher order replacement for Spheres, because Spheres was. And is there any specific reason why you chose this cuboid shape rather than any other fancy shape?
Yeah, that's also a good question, because Spheres was actually spherical, and it was in a sense kind of nicer looking in a way. So also, if you see in the picture I was showing before, the int ball, the JAXA little spherical robot, it looks way cuter than AstroB. But this was also another kind of decision we had to make, trade-off between the functionality and and the design, the look. Yeah. So to allow experiments and payloads to be attached and plugged into AstroB, we decided to have this shape, cubic shape, that basically has this kind of like format or volumes of the payloads that can fit onto the robot way more easily. And so this was a decision made to make the development of these payloads way easier. And also, yeah, because of the all the electronic boards and sensors, packed together, usually take kind of like square shape more easily. It's easier to find boards that have like a square shape rather than circular or other different shapes.
I agree. It's always better to have a shape of that type compared to spare. I mean, spare looks good, but operationally, functionally, I think having straight edges is always better because you can easily attach the various payloads, and you wanted to have a multi-payload platform.
Yeah, so, exactly. Yeah. Completely
All right. So so I'm actually through with whatever questions I had in my mind. We can now, I think, open up if there are any questions from the audience. We can probably take those questions. Okay.
Yeah,
so
sure.
so there is a question which I also had. How much time, resources, and money it took to construct these 3 robots?
Okay. Yeah, that's a good question. All right. Okay. So time. Let's see. That was around 4.5 years from conception to fly into the space station, which is usually kind of fast time for a space project or even for NASA projects. And this was mainly thanks to the fact that the project was not considered as a very high level or very high quality project that usually takes way many more years. If you imagine like space telescopes or other big projects or like rovers and so on, they take way longer. They go through so many more scrutinies and safety and so on. So that's why we were able to do it in a way faster way. And then how much?
Yeah, the budget. What was the cost?
How much was it? Yeah, so the cost, I'm not entirely sure. I can tell you. I think it was around in the order of a few $1 million, something like something between $5 and $7, I think, $1 million in total, including the labor, of course, which is the most expensive thing. But the actual cost to build one AstroB, I remember that from shipping it when you do the insurance or on the shipment, and
write the cost.
Yeah, so there was not expensive at all. It was around 100K, I think, something like that. Even less probably than that. So it's the different components and things together. That actually is not expensive at all. It's the development, of course.
That is of course
the biggest cost.
Correct. So there is a question that the use of impellers is a good idea, but since there is no gravity, then why can't a single AstroB carry the load? Why do you need several of them to do the same thing?
Okay, so actually we have only 2 impellers on each AstroB. There's like 2 counter-rotating impellers on each side, and we have 2 because we want to balance the rotation of one on the other, and we decided to put these impellers because we have so on spheres, for example, we were using some compressed air, compressed CO2 to move inside space station. So it was compressed gas that was used, to propel the spheres robots around. And first of all, it's a bit cumbersome because it kind of pollutes the environment. In fact, some astronauts were actually confessing that sometimes they were feeling very sleepy after using the spheres robots for many hours because they were around this big amount of CO2. and also the CO2 tanks had to be replaced. So we had to we didn't have long or infinite amount of fuel, in a sense, propellant. And if we use the air, and so these impeller motors, we can basically just we never need to replace them, and so just AstroB can move forever inside the space station. And then apart from these two impeller motors that spin opposite to each other, there are nozzles all around the AstroBs, and there's like, I think, 12 nozzles in all different directions. And so by opening the nozzles in different parts of the robot, you create a thrust or a rotation in any direction. And so yeah, this was the reason why we decided to use this.
Okay. So there is a question, can the AstroB module be used without any physical presence of the astronauts? And can the AstroB be repaired from glitches remotely?
Yes, they can. So they can be used without the physical presence of astronauts. And in fact, we are already using them. We've been doing what we call the crew minimal activities. And these activities require a very, very minimal intervention from the astronauts. We just need the astronauts to check on some, to do some kind of very simple checks inside the space station. For example, the lights, make sure that all the lights are on the correct mode, and then check that there is no obstructions in front of the AstroBs, and things like that. So we just need a few minutes from them to check these things, and then after that we just use and operate the AstroB autonomously and remotely without the astronauts. In the future, we hope to be able to even need this additional help from the astronauts. So it's challenging, but we will see how much can be. It's probably really hard to have 100% automation. The curve to make it 100% of the autonomous.
Yeah.
Yes, exactly. So
correct.
If you just need a few minutes of time from the astronauts, it's still a really big success for us. So
correct. It's a good deal. It's a good deal to have.
It's a good deal. Exactly. Yeah.
It works.
Yeah.
Right.
And then the other area was if we can repair glitches remotely. Yes, we can. If sometimes there are bugs or we need to do some updates or upgrades to the system, to the AstroB systems, yeah, we can definitely do some of these repairs remotely. We cannot do them. We cannot do these repairs on everything remotely. For example, if there is another really cool thing about the design of AstroB is that AstroB is modular. So there's all these different modules that are just attached to each other. And if for some reason one of these modules fails or something is wrong, the astronauts just need to pull out this just small part of the modules and replace that. So if that happens, unfortunately, we need the astronauts to do the repair. But we designed everything such that all these repairs can be done easily. So.
Okay, wonderful. So, Roberto, thank you so much. Your explanations have been very, very revealing and very exciting, and really, it's amazing to see that there are these square cuboids moving around fairly autonomously and doing these routine tasks. So thank you so much on behalf of TechFest team, and also on my personal behalf, to regale us today with your deep insight on the design and operation of AstroB. And I would like to thank everybody who is attending this program for their presence. And let's hope that at some point of time, we are able to see the lunar modules or Lunar Gateway, as you said, working with a lot of these small bees moving around. Okay.
Yeah, so I'm very excited about that. And thank you all so much for hosting me tonight. And yeah, keep your interest high in space.